Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Ariel Riyadi and I'm from the Department of Chemical Engineering at Universitas Muhammadiyah Surakarta. And today I will be presenting my research proposal on optimizing biodiesel production using modified eggshell-derived calcium oxide catalyst. So, as global energy demand continues to rise, there is an urgent need for cleaner alternatives to fossil fuels, and biodiesel has emerged as a promising renewable energy source, particularly for countries like Indonesia, with a vast potential for its production. However, to make biodiesel production more cost effective and environmentally friendly, we need to explore an innovative catalyst option. So, the previous research has shown that calcium oxide catalysts are cost effective and efficient for biodiesel production. For instance, Lead et al. At 2016 demonstrate that combining calcium oxide with magnesium oxide could enhance the catalyst performance. Furthermore, using waste materials such as waste cooking oil and eggshell can significantly reduce the production costs and improve sustainability. Then to provide a foundation for my research, let's take a look at two relevant studies. So Tafildari et al. At 2015 achieved a 98.95% biodiesel yield using waste cooking oil and a mixed calcium oxide magnesium oxide nanocatalyst via sol gel method. Conversely, Lee et al. At 2016 found that while a mixture of calcium oxide and magnesium oxide catalyst had a lower yields than a single calcium oxide catalyst, but it's offer a better usability when they using a crude Jantropa oil as the feedstock with a high acid value. So, in my research, I will use waste cooking oil as the feedstock and a mixture of calcium oxide from a calcium chicken eggshell and magnesium powder as the catalyst. And this combination aims to improve the biodiesel yield and cost effectiveness of the biodiesel production itself. So the research addressed three key questions. So first is how does the reaction temperature affect the properties and performance of modified eggshell-derived calcium oxide catalyst? And then the second question is how does reaction time influence these properties and performance? And the last question is what is the optimal amount of catalyst to maximize biodiesel yield from waste cooking oil? So from that three key questions, so the objective of this research first is to investigate the effect of reaction temperature on the properties and performance of modified calcium oxide catalysts. And then the second objective is to study the effect of a reaction time on these properties and performance. And the last objective is to determine the optimal amount of catalyst needed to maximize the biodiesel yield. So, my research design is focused on optimizing three main variables to maximize the biodiesel yield. The first variable is reaction temperature. So I will vary the temperature at 50, 60, and 70 degrees Celsius. And then the second variable is a reaction time at 1, 2, and 3 hours. And then the last variable is catalyst load at zero point 0.5, 2, and 3.5 weight percent. And I will use the Taguchi method to effectively determine the best combination of these parameters. So Taguchi method is a useful statistical method for optimizing experimental process, and it is beneficial in identifying the most influential variable and their optimal level with a minimum number of experiments, and the method is use orthogonal array to systematically vary and test different parameters, reducing the time and cost typically associated with such studies. And this research stages consists of four stages. The first stages is the research design. In this stage, I will collect the initial data on waste cooking oil samples, catalyst preparation, and the equipment setup. And then the second stages is the catalyst preparation. I will prepare and characterize the catalyst by calcining the eggshell into calcium oxide and mixing it with magnesium oxide. And then the third stage is conducting experiment using the Taguchi method, and I will optimize direction, temperature, reaction time, and catalyst loading using Taguchi method and collecting the biodiesel yield data. And then the last stages is data analysis, and I will analyze the data to determine the optimal condition for maximum biodiesel yield and present findings with tables and graphs. And these last steps aim to develop an efficient biodiesel production using a modified Eggshel-derived catalyst. And for my catalyst preparation, first is wash, dry, and crush and ground the eggshell into a 100 mesh powder, and this powder was calcined at 810 degrees Celsius for 3 hours. Then combine the calcium calcium oxide powder with magnesium oxide powder in 1 molar ratio, and then mix it with distilled water to create a slurry, and then we will dry it and calcine it again. And then this modified calcium oxide axial catalyst was then used for the biodiesel production. And for the biodiesel production itself is perform the transesterification process with a 12:1 methanol to waste cooking oil mole ratio, and the modified calcium oxide catalyst is stirred in methanol for 5 minutes to create the methoxide, and then which then it's will mix with heated treated oil with cooking oil and vary it at 50, 60, and 70 degrees Celsius and stir it for 1, 2, and 3 hours. And then after the separation or 24 hours of settling, the biodiesel separate from the glycerol byproduct, and then we have the biodiesel. So here is the proposal timetable for the research, and it's outlined the schedule for each stages, and from catalyst preparation to data analysis. And this timeline is ensured that I will complete the project systematically and efficiently. So this is the reference list here is to provide the foundation for my research and support the methodologies that I have chosen. So thank you for your attention, and I'm now happy to take any question you may have regarding this research proposal. Wassalamualaikum warahmatullahi wabarakatuh.